A census taker visits the house of a mathematician to ask him the ages of his 3 children. The mathematician gives him a puzzle to solve. He says that the sum of the ages of my 3 children is the house number, and the product of the ages of my 3 children is 72. After thinking long and hard, census taker says, "Well, I don't know the ages." The mathematician then says that, "Oh, I forgot telling you that my eldest child loves chocolate chip cookies." And the census taker then writes down the ages and leaves. How is it even possible? Think about this problem a bit, and when you're done, you can come back to see how it was done. So I assume you actually tried very hard finding out the solution of this logic problem. At first it seems impossible, almost impossible, that how could he even first say that, oh, okay, I don't know the ages, because there is not much information provided in the question, and then he suddenly says that, oh, I know the ages, only after the mathematician says that my eldest child loves chocolate chip cookies. So what's up with that? We'll find out. So first of all, in any logic problem, what we do is that we write down the information so that it is convenient for us to understand it, comprehend it. So first of all, it says the product of the ages is 72. So I'm just going to write down the 3 ages of the 3 children that actually product to 72. For example, 1 times 1 times 72 is equal to 72, doesn't it? These could be the 3 ages also. I mean, it is very less probable that one child is of 72 is 72 years old and the other 2 are 1 year old. Almost impossible, but we'll just consider it because it could actually happen. In the world of logic, anything is possible, although it is very improbable. Excuse me for that. So 1 times 2 times 36 is also 72, and also 1 times 2 times 1 times 3 times 24, and 1 times 4 times 18. 1 times 4 times 18 is also 72. What else? 1 times 6 times 12 is 72. 1 times 8 times 9. 1 times 8 times 9 is 72. And then we have, I guess 2 times 18. And I guess we have a 2 times 3 times 12. And what else? 2 times 4 times 9. 2 times 4 times 9. And what else? 2 times 6 is also there. So, I'm just going to write it here. 2 times 6 times 6. 2 times 3 times 8. And 2 times 3 times 4. 2 times 3 times 4. And I guess we're done with that. So these are the possible outcomes of the ages of the children, right? So because they all are the factors of 72. These are all 3 numbers that actually, if you multiply, you get the product 72. So far, so good, right? Okay. Census taker could actually figure this out, yet he still said that I do not know. However, when he visited the house, he actually knew the house number. Census taker did know the house number. We do not know what house number was because it is not given in the problem. However, census taker knew. So let's see what house number could have been. So if you add these numbers, because it says the sum of the ages is the house number, you get 74, you get 39, you get 28, you get 23, you get 19, you get 18, you get 22, you get 17, you get 15, you get here 14, and you get 14 again, and you get a 13. So these could be the possible house numbers because these are the possible ages, and if you sum each of them, then you get these numbers that could be the possible house numbers. So, if I were the census taker and I just know the house number, I could just easily figure out what the ages of the children are. For example, if I went to the house and it was house number 18, for example, I just know that, okay, the house number is 18 and only possible numbers that actually multiply up to 72 and add up to 18 are 1, 8, and 9. So I just know the ages of the 3 children is 1, 8, and 9. So isn't it actually very simple that I just know it? But the census taker says, I do not know the ages. Why did he say that? even though he knew the house number, still he did not figure out the ages. That must mean only one thing, that the house number was something that actually came twice. That only tells us one thing, that the house number must have been 14. Because the house number was 14, he had two possibilities left. Because these numbers, 2, 6, and 6, and 2, 3, and 8, are both the possibilities that add up to 14 and multiply up to 72. So this tells us the house number was definitely 14, so that he could not figure it out. So this was the house number 14. Because if anything else was the house number, for example 23 was the house number, then he would just simply tell the ages of your 3 children are 1, 4, and 18. I actually get it. I'm too smart to actually calculate anything, right? So he just say it simply, but he did not say that. He said that I do not know the ages. So that must mean the house number must have been 14, because this is the only case where you'd still be not knowing the ages, because it comes twice. So he says, I do not know the ages. And then the mathematician says, okay, I forgot telling you that my eldest child loves chocolate chip cookies. Well, most of you will actually be trying to decode what chocolate chip cookies is trying to convey us. Well, it's just a decoy. It is just trying to distract you from the real information, that is eldest. See, the eldest child, the mathematician says the eldest child. And when he says eldest child as well, not, it doesn't say children, eldest children, no. It is only talking about a child that is the eldest. In this case, we have two elder twins. And there is no child who is, the eldest of all these three. Well, in this case, we see the child who is 8-year-old is the eldest of them all, who likes the chocolate chip cookies. So it definitely has got to be this combination of the ages of the children, 2, 3, and 8, because they add up to 14, they multiply up to 72, and they contain an eldest child. So census taker writes 2, 3, and 8 and walks away. I hope you enjoyed it. Thank you for watching.